though, besides you.
Why the fuck do you?
What? I thought that. Okay, that doesn't count. Oh, I built right there. Nope, I stared myself.
5 o'clock.
Oh, come on, man. Flag it. You're not the mobile player. You're not the mobile player. Oh, shoot.
Dare call them. How?
Sharpness. Your time was wasted. No, mother thing quesadillas. Don't order anything. Don't order the beans. I don't order anything. Order me tomorrow.
All right, hi everyone. Thanks for coming to class today. So today is Python class, as you guys all probably know. So just as a reminder, this is our second to last class. So next week will be our last class. And last week we built a couple of games. Those were pretty simple games. So today we're going to try to create a more complex game. So we're going to create Tic-Tac-Toe, like a 2-player Tic-Tac-Toe game that you can play with like your parents, your siblings, your friends, or whatever. And it'll be on the computer, obviously. So I'll start out by sharing my screen. Can everyone hear me?
Yeah,
Yeah.
I can.
Okay, cool. Yeah, so I'll start out by sharing my screen so you guys can see how the game works. So this is just an empty file for now, but I've already typed up the game. So X's and O's, obviously, in Tic-Tac-Toe. So
I have a question.
yeah,
Is this lesson basically going to be using everything that we've learned so far?
I wouldn't say everything exactly, but it'll be using a lot of the concepts that we've learned.
So the major concepts?
Yeah, but yeah, so I have a board here that looks like this. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Those represents like the different spots on a tic-tac-toe board. And then obviously you have X's and O's. So where would you like to place your X? So like this would be the X's turn. Then you can, for example, put like 5. So then X is now in the middle. And it switches the turn to an O. And then where would you like to place your O? You just place it there. So I'll just quickly go through this game. And then it says game over, X is 1 after he finds 3 in a row, like that. And then it says, do you want to play again? You can either pick yes to play again or no to just end the script. So that's the basis of what we'll be creating today. So yeah, so let's get started on that. So the main thing that we want to do, we go back here, we see that it prints out the board every time a turn is going on. So let's start out by creating our board for our tic-tac-toe. So we'll keep our board as like a dictionary. So we'll call it the board, just simple like that. And then I'll create, a list of all the different keys in our board. So that would represent like 1, 2, 3, 4, 5, 6, 7, 8, and 9. So this would just represent all the 9 different spots on our board. So I'm just going to use a list for now. And then ideally our dictionary. So what our dictionary will hold, the board, is it will hold key to value pair, as you guys remember. So the key will be the spot on the board. So if we go back to what our board looks like, we have 1 through 9. So the key will ideally be like 1 corresponding to whatever the current value is there. So in the beginning of the game, it'll be a 1. Then obviously, if, so I'll type this out. So this is what our dictionary would kind of look like, and so on. But yeah, so and then once, for example, so the first space represents a 1 in the beginning, or like the 5th space represents the 5. Then after an X decides to place there, then it changes the value from 5 to X. So if we have like 5, then after that turn, then this value would become 5X, if that makes sense. So that's basically how we're going to change our dictionary. So now let's just create this dictionary using our keys. So I'll do a for loop. For key in board keys, we'll say the board key is equal to the string representation of that key. And I'll just print out the board so we can see what's happening.
Wait, what do you mean by the top text that's common?
Sorry, what?
What exactly is the significance of the top text?
So yeah, this is what I'm trying to explain what is going to be in our dictionary. So our dictionary you see right now, I just created the dictionary and we have a 1. So like each one of these keys, so like we have 1 to 1, 2 to 2, 3 to 3, So each one of those keys represents a place on our board. So that first one will be like the 1, the second one will be the 2, and so on. And then as we add X's and O's, we'll change the values to those keys to X's and O's based on whatever the user does. So yeah, so our dictionary is created. This is what we want. Sorry, was there a question?
Yeah, I had a question.
Mm-hmm.
So how does saying the board and then having key in the brackets equals string brackets key, like, pose significance into this like thing?
So yeah, so what this line is doing, so for key and board keys, so we've gone through that. So each key represents an item in this list. So remember, this is just a list of all the keys that we want, 1 through 9. So then what this line is doing is basically saying every key, I'm going to say the board key 1 is equal to, actually, since it's a string already, we don't need this str, but since it's so basically this is just every time you're adding to our dictionary. So the first item that we add will be with the key value of 1 and then the value of 1. So like this is basically just adding this to our dictionary. So you see how we have an empty dictionary and then at the end we have all of this in our dictionary. So this line is basically just adding to that dictionary.
So why is it better not to have the S to define the key?
Sorry, what?
Why is it better not to have the str to define the key?
Sorry, I can't really hear you.
Oh. Well, so
Can you
why
repeat
did
one
you? Sorry, yeah. Why is it that we took out the str then?
Oh, because this is already a string. So I'll just run it again. Yeah, and the same thing should happen. I was thinking it was an integer because it was a number, but it's actually already a string, so we don't need the str. Cool. So now we'll define sort of like the main method. This is like a method that we'll use to represent our game. So I'll just call this game.
Just one thing, I have 2 questions.
Mm-hmm.
First of all, the board in the brackets, what exactly is the significance of the brackets?
So that means it's a dictionary. We went over that last class.
Okay. And second, for the board keys, since keys in those 2 brackets, is it referring to 1, 2, 3, 4, 5, 6, 7, 8, 9?
This?
So key equals the dictionary of 1, 2, 3, 4, 5, 6, 7, 8, 9.
Oh, so this is a list. So this is just a list of all of our keys.
Oh, so it's saying the definition of the list is the key?
Sorry, what?
So the board key equals key is basically saying the definition of the list is the key?
It's basically adding to the dictionary. I just went over that. So we're basically adding different items to our dictionary with a corresponding of 1 to 1, 2 to 2. So we're going through this list and then basically adding it to our dictionary.
So it's just showing that the definition of the list is equal to the key.
Yeah, sort of. Yeah. Okay. Yeah,
Excuse me. Sorry. Just one real quick question.
Yeah.
Yeah. So why is it printing 1, 1, 2, 2? So why is it? Sorry, I missed that. Why is it printing all of them twice, each number?
Because it's a dictionary. So remember, in dictionaries we have keys and values. So each value is representing the current value at our square in our tic-tac-toe board, and then this is just a key that I'm using to represent the index of each value, each square in our tic-tac-toe board. So remember, we have 1 through 9, like this. So the value is what is the value at that square, and then the key is the index, basically, to access that square.
So key is already a default term, like so the text editor or the prompt already knows what key means, basically.
In this case, the key is just like I'm just using it as a for loop. It's well, I'll get more into this. I need to move on. So I'll start out with this. So we'll start out with the variable that represents the turn. So at the beginning, obviously, it begins with x. So the x's will be our first player. And then, so at the beginning of each run, what we want to do is just print out the board. So I'll print. So actually, to create something like that, what we want to do is create a method to print our board, or like a function. So you can create this however you want. I just found like a simple way to do it online to make it look good. So I just copied and pasted it here. So what this is doing, so if I run this now, print board on the board. So the board is representing our overall tic-tac-toe board. And then I'm running print board on that board. And then it refers back to this function that I created, print board. Yeah, sorry. I'll copy and paste that here. Formatting might be a bit off, so make sure when you copy and paste it back into your text editor, you have all the indentations correctly.
What do you copy paste?
Huh?
What exactly did you copy paste?
How I'm going to print out our board. It's in the chat. Yeah. So we print out so I'm printing out basically each individual value of the board. So the board in this case is representing the board. So board 1 will basically look at my it will basically look at my dictionary, which is over here, and then it says print board 1. So it'll print whatever the value at 1 is. So in this case, it's a 1, and then a 2, and then a 3. So then if I were to just run this now, what we have in our program. Yeah, so I messed up some indentations.
Isn't it just easier if you like if you just replace the like if you remove the entire board parameter and you just do the board for each of the print statements?
Sorry, I couldn't exactly hear you. What did you say?
Isn't it just easier if you remove the parameter board and instead you just use the board for each of those?
Yeah, so I mean, either way it would work, but usually it's nice to maybe sometimes you want to print multiple boards if you have multiple tic-tac games going, if you want to modify it like that. So this just ensures that we're printing on that specific board. But yeah, the way you said it is completely fine too.
Could you also take the index when we were writing there?
Sorry, what?
Could we have also taken the index of each key if we were trying to put it in there?
I'm not exactly understanding your question.
Like, could because like board keys is written over there, could we have taken the index of each number and then like put it in there when we were doing print board?
Oh yeah, that's another way. But yeah, this is just the easiest way because we're directly accessing the board and then just getting each value.
Right.
Looks like Python is not liking my indentation. So
Wait, for some reason when I type in def game, the def is showing up pink on Sublime Text.
Oh, that's probably because your brackets or something is probably off there. You might have been missing some brackets there.
Sublime did it though.
You should check the brackets again.
I see my
sorry, I think something got messed up with my indentation when I was copying and pasting. So I'm just gonna quickly type this. So yeah, so when I ran this now, you see nothing got outputted. So what I want to do, this is my main function that I'm going to use for this game. So I'm just going to call that function down here. So that basically allows me to run this function, whatever is in this function. So in this case, I just created a turn. This is irrelevant right now, but then it's just calling the print board function. And then when I run it, then we get our board looking like that. So yeah, so that's a good start. So now what we can do is sort of start our game. So we have a turn variable, and then we basically need a while loop that will basically continuously be printing these, basically continuously start this game until either the game ends or they run out of turns or there's a tie or something. So we'll just keep this as a while true, so that this game, the while loop will always be executing, and then we want to break once the game ends. So now I'll print out, we have to print out whose turn it is. So we'll say it is your turn. Turn. And then we need to ask them for their input so that they can specify where they want to put their X or O on the board. So where would you like to place your, just say turn, like that. So now I'll just break after this just so their while loop doesn't continuously execute. So where would you like to place your X? And then I can input like a 1 or something. So yeah, so that's what we wanted. So we have our input there working. And I did something like this. Where would you like to place your turn. So the turn, remember represents X or O. So in this case, where would you like to place your X? So it looks nice like that. And then basically what I want to do is check whether this input that the user gave is already something that has been placed on the board. So this \n just creates a new line. So it just looks nice. So I can put the output on the next line. But yeah, so I want to check whether that's already on the board. So what I can do is I can say if the board move. So remember, move is representing the value that the user is inputting. \n is creating a new line. So after if he has, yeah. And then I can say if this
\n does not show up in quotes. I mean, it doesn't show up like purple.
make sure you're using a backslash, not a slash. And then we'll check if this board is equal to the, so what we want to do here is basically check that the whatever is at this current location is equal to the move that they give. So for example, if they input a 1, so this will access whatever value is at the board at key 1 would equal to that value. So for example, if it's already, if there's a 1 already there, like if we show in our dictionary, sorry, something's wrong with my laptop. Okay. But yeah, so there's a dictionary, so you notice that we have a 1-to-1, but then if that gets changed, then the value being X, so then this if statement won't be true. So this is basically checking if there is nothing else that has been placed at that spot in the board. Then we want to change that value if it's not been changed yet to whoever's turn it is. So remember, turn is just representing the X or the O. And then I'll also keep track of the number of moves that are being done by the user. And then we'll say, we'll increase that number of moves as well. And then else, if something has already been placed at that spot, then what we want to do is just print out that place has already been filled. \n, and then we will just continue, which basically just means go back to the top of our loop so that they can input a new number. So yeah, so let's run this just to see. So yeah, where would you want it 1? Then it's just going to print it out again, and then you see how it changed our value at 1. And so we haven't changed the turns yet, so it's going to keep printing X for now. But for example, if I were the user and I actually inputted an A, then you see it gives me this error. So you see that I get a key error A, meaning that the board cannot find a key that has the value A in it. So it's getting an error. So one thing that we can do here is basically take this. So this is, remember, is sort of a comparison. This will always evaluate to true or false. So if I take this and I'll just assign this to check move. So what this is basically doing is taking this check move and assigning it to the Boolean value of this. So if that spot is open, then it'll be true. If it is not, then it'll be false. So I'll keep a check move here. So now something new that we have not gone through yet is something called a try and except. And then we'll just print out, I'll explain exactly what this is doing.
I have a quick question.
Yeah.
For the input, would you put integer before the input because you're inputting an integer?
Yeah, so that so in this case, since our dictionary is only containing strings, we don't need an integer because everything's a string.
Okay, yeah.
Mm-hmm. So yeah, so what this is doing is it's basically trying to assign this variable to the Boolean value of this, and then it's basically saying, oh yeah, let me add this. It's basically saying that if a value error is thrown by Python, then instead of completely crashing my program and ending my program, what I want to do is just print out and tell the user that it was an invalid input, and then continue my loop again and go back to the start.
Oh wait, did you change the if the board move equals str move?
Yeah, so I made it into a Boolean check move. It's like that,
Okay.
which I assigned over here. So what this is basically saying is try to assign this value, but if an error is thrown, then just print this out and continue on with the loop. So I'll run that now.
Oh, excuse me.
So now if I input like an A, then you, did I mess up something? Maybe I did not save. Oh, let me just put this in parentheses like that. Oh, sorry, I put value error. See, that's the problem. So it's actually a key error, and I put value error. So that should be a key error there. That's the problem. And now if I run that again, I input an A, then it says invalid input, please try again. And then it prints out my board. And then obviously I can input valid numbers like that. But yeah, so that's working. So now this makes sure is that our input is a valid input.
Oh, excuse me, just a quick question.
Mhm.
So if we scroll down, where if you define move when we're saying like the board, then in brackets we're putting move, where have we
So move
defined
is
it?
the input from the user.
So it's basically saying where would you like to place your piece, and then it's basically asking for whose turn it is.
So it's saying, it's not asking for a turn. So it's saying it's X's turn in this case. And then it's asking, where would you like to place your X, basically to the X user. And then it's, you're getting the value there. And then it basically changes the value on the board based on that.
So where do you actually find then like locate the area and then convey it to the editor? Where do you convey the area where you want to place the X or the O?
Through this. So this is basically changing my dictionary so that, notice how I explained this up here where if, so it starts by default 5, 5, then if I were to input an X there, then it changes to the 5X. So that's basically what this line is doing, changing from like a 5 to an X, or changing from like a 1 to an X based on which value I input that X at.
So basically it's saying that if it is X's turn and then you place it in an area where it has not been placed, then the number of moves will go up to 1, else it'll say the place has already been filled.
Yeah.
So how does that check move equation basically convey that? The board parenthesis move equals str brackets move?
So this check move just checks whether that's already a place that has been, like whether like an X or an O has already been placed there. And then if it hasn't been placed there, then it changes it to whatever turn it is. And then otherwise it says it's already been filled. That's all this if statements do.
What is the game parenthesis supposed to mean?
So that's just a function. I named it game, like our main game, and then I call it down here. Sorry guys, I need to move on so we can finish this up today. So now what we can do is basically just every time this while loop runs, if my turn is equal to an X, so yeah, actually someone just asked a good question in the chat. So if you input a number outside of the 1 through 9, so for example, if I input a 10, then it still says invalid input, because what this key error is checking is whether that input is a valid key in my dictionary. If that makes sense, yeah. So yeah, so if turn is equal to X, basically at the end of my while loop, then I just want to change it to an O. And then otherwise, that means our turn is an O, so I want to change turn to X. So this is basically just reversing whoever's turn it is at the end of my while loop. So then now we can run this one more time. It says X's turn, I'll place a 5, O's turn, then I'll place a 2. So you see now how it's changing O's and X's inside. I can just keep playing on this. But then obviously now we have 3 in a row here, but the game doesn't end. So now what we want to do is to add ending to our game. So we can tell when the user has won or whether there's a tie or whatever it is. Oh yeah, if you guys are running your program and it's not stopping, you can do Control-C. I've said this before, just in case you guys forgot, and that'll stop your stop it while
And
it's
how do you
running.
get the tic-tac-toe board itself?
This?
Yeah.
Okay.
Does it come when you name it tic-tac-toe.py?
No, because I called a print board at the beginning. So this is the function that we created to print everything.
Oh, so
Got it.
essentially what it's saying is that like the board move equals turn means it'll replace each index along with the turn, whether it's X
Yeah.
or O. Correct.
I was just wondering how like, the board is made.
So yeah, the board I just printed out like this. I just had a bunch of print statements to print
Okay.
out the board.
And we don't need
Yeah,
to
okay.
memorize the printing.
Yeah, you don't need to really memorize it. Okay. So now, every time this while loop gets executed, we basically want to check whether the board is in a winning state. So after we do all of this and edit whatever the current user's move, we want to check if it's in a winning state. So how can we define whether the board has been won? So we'll create another method for that.
Excuse me.
Yeah.
When I tried to run my code right now, when it ran, it said continue. It had a syntax error and was not properly in loop. What is that?
Okay, yeah, it's hard for me to debug like this. So I'm gonna try to finish teaching all of this, and then if you have more questions specifically about your program, I can answer at the end. So for now, hold off any like specific questions about your program, because anyways, this code will be posted afterwards if you want to check it.
To finish it off, you just have to basically convey exactly how you want the winner to be decided.
Yeah, exactly. So how can we check for wins? So we have different winning states. So if you guys have played Tic-Tac-Toe, obviously you know. If you haven't, then sort of just follow along here. So basically, if you have 3 in a row across the top, so obviously you can only win when you have 3 in a row, and then you can have across the middle, you can have across the bottom, and you can have it down the left side, down the middle, and down the right side. And then you can have like I'll call it left diagonal, starting from the top left, and then right diagonal, starting from the top right. So these are just the different ways that you can win in Tic-Tac-Toe. So what would represent across the top in our board? Which 3 numbers in our board? Can someone type in the chat? Yeah, okay. So 1, 2, 3.
Sorry.
So basically what we want to do is check if all of those values are equivalent to each other, meaning it's all X's or all O's. So we'll say if our board, so notice how I passed in 2 parameters into this function, that is our board, and then whoever's turn it is. So I'll say if board, 1 is equal to board 2 is equal to board 3. So this is just checking whether across the top, all 3 are equal. And then if that is the case, meaning that this player has won, then I just want to print out the board one more time, just to show the winning state of the game. Then I'll print out just like a game over, just to signify to the players that it's done. And then I'll say whoever's turn it is has won, just like that. So yeah, and then basically in a Tic-Tac-Toe game like this, what we have to do is do that for each of these. So I'm just gonna quickly do all of these. You guys probably understand the point by now about how these if statements are working. So I'll keep them as elifs. So 4, 5, 6, remember, represent the row in the middle. 7, 8, 9 represents the row on the bottom. And then down the left side, so in our board, the left side would be 1, 4, and 7. So you just have to change all these values. And then we have 2, 5, 8. 3, 6, 9. So these are just all the different combinations that I'm writing. So if you guys don't have all of this code written down already, don't worry about it right now. It'll be posted right after class, or if you're unable to like write it all down. Then we have our left diagonal, which would be 1, 5, and 9. And then we have our right diagonal, which is 3, 5, and 7. And yeah, so notice that we have print statements in each of these, but we're not really defining anything that says like, oh, this is the end of the game. So what I'll do, so basically we will return true for each one of these. So basically say that, okay, the game is over. And then if none of these get executed, then we'll just return false, meaning the game is not over. And now what we'll do is, after we do all of this, so we edited the board, we changed our moves. So now what we want to do is basically check whether this function returned true. So we say if check win on the board and turn. So you can either say if the check win is equal to true like that, or you can just say like that. So Python, if you just have something like that, then it basically means if this is equal to true. You know, the equals true is optional.
Wait, can you just go up for just a minute, please?
Yeah. Yeah, so in the chat, they're saying that, yeah, you can set up a dictionary that has a list of all the different winning combinations. That's another way to do it, yeah, but this is just using these elif statements and return values in a function. So yeah, there's multiple ways to do this game, obviously. But yeah, this is just the way we're creating it today. So I'm saying if this check win, which means it is a win, then what we want to do is break from our loop. Break will basically just stop executing our loop, meaning the game has been terminated, and it'll only happen if this returns true, meaning it finds like a combination of 3. And then one more thing is there's only 9 spots in our tic-tac board. So we have our number of moves. So the game will also end once there is a total of 9 moves that have been done. So if the number of moves is equal to 9, meaning all squares are basically filled up, then I'll print out the same thing, print out game over, print there was a tie, and then we'll break again. So meaning we don't want to keep executing our loop because there was a tie, so the game is done.
For me, when I'm compiling, it's showing an error like a non-ASC double I character.
Yeah, so can you just type that into the chat? Caitlin should probably try to help if she can help with it right now. If not, just ask us after. But yeah, so we have all of these checks. So we'll run our program now. So we have it is your turn X. So I'll place 5, and then it changes it to an X. You can quickly go through this if you would like on your own computer too. But then, yeah, so we see we have all 3 in a row. It recognized that we got 3 X's in a row. It says game over, and then X says 1. And then same thing, if O were to win, I can make O win real quick. And then it says O has 1 after it finds 3 in a row here. So which line are you guys getting that error? The non-ASCII character?
Line 16.
In my program, which line is it?
I think for you it's 15.
15, this line?
Yes.
So yeah, so just make sure that when you guys are casting, or you're not casting anything to like an integer or something, but yeah, it could be a copy and paste from the Zoom also. So maybe try just retyping this out how I did. Remember, I was getting like an error. Yeah, so someone's asking about a tie, so I'll show when there's a tie. Yeah, so you see we had a tie. Oh yeah, so there's a problem right there. So it doesn't really print out the final board when there's a tie. It only printed out the last one, and it said there was a tie, which is true. So I'll just add one more line that does a print board on the board. So I can do this. Yeah, and then it printed out the board, said game. Oh, I didn't even realize X got 3 in a row. But yeah, so this should work now. So now what we want to add is something so that our game can continue to execute, and then the user can basically decide whether they want to continue playing this game or not. So we have our while loop here, and then we have break statements when the game is done. So outside of our while loop, so make sure your indentation is in line, the same line as this while, so that it's not inside your while loop. And then we can just say this is a restart, and we ask the user, do you want to play again? And yes or no, basically. So that's how we'll do it. I'll just do a new line also at the end. And then I'll say if this restart is equal to either a lowercase y or to an uppercase y. So that handles casing. So then we will do we'll want to call this game function again. But at the same time, if we were to call this game function and play, so if you guys see, so it says X has 1, so yeah, we did that, and it says, do you want to play again? So I can input a yes. But then you see it inputs, or it prints out our board from the previous game. So how can we reset our board? So same thing that we can do is basically take our for loop that we created in the beginning, which basically defaults, it creates the default board. We can just add that back in here. And then you see now we have our board is basically refreshed into a fresh board. So then it defaults our game, then you can play again. So yeah, that should be everything for Tic-Tac-Toe. Yeah,
Wait, what do you do? Excuse me, I have a question.
Yeah.
What do you do if the person puts N?
Oh yeah, I can just show that. Basically, so if the person puts N, then this won't be executed and then the program will stop. Because this is only an if statement for the Y case. So technically, if they were to input anything but a Y, then the program would stop, not even just an N. You see if I put like, I don't know, something random like that, then the game will end. Are there any other questions or anything that you guys want me to explain again?
Can you please go down to the yeah, okay, so never.
Cool.
I
yeah,
have a question.
Oh yeah.
It's not really about this kind of, it's kind of just a general Python question.
Okay, yeah, that's fine.
How do you write if something's like not equal to it? Like you can write this is that. How do you write this is not that?
Oh yeah, I'll just show that right here. So basically say if the turn is not equal to an X, like that, then it means it's an O, so I want to change it to an X, otherwise I'm going to do an O. So this is how you do not equal to.
All right, thank you.
All right, cool. Yeah, so if you guys didn't get all this code down, don't worry. I'll post this right after so you guys can play around with this. And yeah, so you can show your parents or whatever.
Can you please just keep the code on? Like keep it on this tab at this height.
Or it'll be posted right after class. So I'm going to move on to another topic for the last 15 minutes or so, and then you can use it after. So yeah, what we're going to do now is learn about classes in Python. So you guys are asking a question about a project. So next week we'll probably do another project in class, and then we can, if you guys really want us to like assign like an overall project even after class is done, then we can do that as well. But remember, the homework is never like required or anything. It's just for fun. So I can just point you guys to resources that you guys can use to work with Python. So yeah, so I'm just gonna demonstrate classes in Python. So we'll create a vehicle class. So I'll name this vehicle.py. So classes are, if you guys are in the Java class, we've gone over this the past couple weeks. Yeah, next week is the last class. But yeah, so we've gone through classes the past couple of weeks in the Java class. But if you guys are not in the Java class, obviously, then a class is basically a way to just create a representation of a certain object that has different attributes. And all these different attributes can be defined by you. So yesterday we created in the Java class, we created like a circle class or a square class that basically has all these different properties, has like the radius of a circle, and then you can calculate the area and the perimeter of that circle. So just basically like an object that has different sort of attributes that you want to compute as a programmer. So in this case, we'll create a class called vehicle. So this is how you define a class in Python. And one thing that whenever you need to create this sort of thing, you need to have a method that defines how you're going to create your object. Basically, everything that goes into this object. So the default for Python is you create something like this called an init. Then you pass this self. I'll explain all of this. And then so don't worry about what I'm writing right now. Yeah, so what I did here was I passed in these 4 different parameters: self, make, color, and gas tank. So if you guys are in the Java class, self is pretty similar to the keyword this, if you guys recall, but self basically refers to the current value in your class. So self.model basically creates a model variable specifically to my vehicle class that represents whatever the model of my car is. And then make is obviously whatever the user were to pass in as that model. And self.color creates like a variable just for my class called color, and then assigns it to whatever color is created. You'll see this, same thing for gas tank. And then I just created this variable, nothing relating to what the user is doing, that basically keeps track of my gas tank, how much gas I have in my gas tank. And then one thing that we can do is basically create another default method in classes called the string method, and we'll pass in the self there too. So what this is, this str.
Wait, the def init just defines all the variables?
Yeah, so I know you're in the Java class, so it's similar to a constructor in Java. So yeah, so now with this string, what this basically does is returns whatever the string representation of your object is. So you can define this to however you want it to be, but so in this case, I'll just make it so we have our model, then we have self.model, then we have our color, self.color. So this is completely up to the user or the programmer on how they want to define this. So I'm doing a casting to a string here because this is a number and I want to be able to print this in my string. There we go. Okay. So yeah, so this is how it's going to look whenever I want to print something. So now what I can do is, this is a pretty simple creation of our class. Then what I can just do is create a my car, and we'll say it's a new vehicle. So this is how you create a vehicle object now. And then, sorry, I don't exactly remember if we went over what this sort of means, but when you have a parameter that looks like this, and you set equals to 20, that basically creates like a default value for that parameter. So it's like optional whether you want to include that when you're creating your object. So it takes make, color, and gas tank. So for now, I'll just pass in make and color since gas tank's already defined. And we'll just say it's an Acura, and it's black. So that's the color of our car. And then what I can do now is basically say print out my car, and I can just print out my car like this. So now if I run this, and you see it prints out my car, model Acura, color black, tank capacity is 20 because that was the default value we created in our constructor, and then the current gas is 0. So when I call my car like this, it basically by default it tries to find this method in my class and then prints out whatever representation I defined there. So for example, if I were to not actually define this in my class, so I'll just comment it out for now, pretending it's not there. If I were to run the same thing, then Python will just print out this like nasty like hex like this code that's not really like user friendly, so it doesn't really tell you anything about the car. But yeah, so if you use this str, then it allows you to print it out nicely, so you can have like a good representation of that. So now we'll just create a couple more cars. Another car. Say this is a Mazda, and this is green. Not a good color, red. And then we'll say our gas tank is only 10. So this basically says that the gas tank is 10, and then we can print that out as well.
I have a quick question.
Yeah.
Couldn't you
Me
just
too.
couldn't you just make a dictionary
For what?
for this? Because like when you print it, it shows like how like a dictionary would, right?
Like you mean like that? Oh, you mean like when I'm printing it out like that? So yeah,
Yeah.
so I haven't gotten to everything that we're gonna do with the class yet. So this is like not the point of the class, but this is just how we create these default methods in the class to print out like string representations. So now my vehicle, one thing that I can do is basically add gas to that. This is not something that you can do with like a dictionary.
Excuse
But I
me?
want to create a method that adds gas to my car. Yeah, is there a question?
Yeah, I'm sorry. I have a lot of questions. It's kind of confusing for me.
Yeah, no problem.
Yeah, sorry. The first one, my car. I noticed that you didn't put in a number for the
Yeah, so the reason I did that was because gas tank, as I was just saying, is equal to 20. So that's like a default parameter, meaning if I don't specify anything for that third parameter,
just
then it will
specifying
default to
what the
20.
gas tank value is. Okay.
Yeah. So notice how init and string are blue, these colors, which these basically mean that they're like Python specific methods that are by default, but add gas is just like a method that I create on my own to add gas. So we'll take in the number of gallons that we want to add to our tank, and then what I can do is I can just print adding this many gallons to adding gallons to gas currently in the tank. So it's basically saying how many are already in my gas tank, and then it's saying how many it's going to add. So now what we actually need to do is add that gas to our current gas. So this basically adds the gas to our gas tank, and then we can say if our self gas is greater than this gas tank, then we want to print out the gas tank is full. And then I'll set, so notice that if we add the number of gallons to our current gas and it's greater than the gas tank, then we want to set back that current gas to whatever the value of the gas tank is to make sure that it doesn't exceed the total number of gas tank, the total gas tank capacity. And then otherwise, we can just print out successfully added gas. So yeah, so this is just the method that I created to add gas to our gas tank in our car. So now, one thing that we can do is we can just say my car dot add gas, add gas, and we'll add, let's say 15 gallons, and we'll do another one where another car dot add gas. We'll try same number, 15. So notice how this one's 10, but I'm adding 15. And then I'll print out the new values. So now if I were to run this, so we see we get our two cars, and we say adding 15 to 0 currently in the tank. So we currently have 0 in our tank, and we're adding 15, and it successfully added the gas. That's good. Then we added 15 to 0 in our tank, and then it's saying that the gas tank is full. So then now we see that our current gas is 10, which meaning it's full. And then we have our current gas for our other car. So yeah, so this is a pretty quick, simple explanation of classes. Notice how this is the main thing that I want you guys to get from this is that a class is basically just an object that you can create like about anything that you would want. So this is just like a vehicle class, and you can have all the different methods that you would like to add, and then obviously different attributes of that vehicle or whatever object you're creating. And then this is how you guys can create those objects and then call methods on it to modify the different values. And yeah, this is like how the basis of different games. Can you guys not spam the chat like that? Yeah. So are there any questions on this? Yeah, so the inheritance, what we did in Java yesterday, similarly can work in Python. I didn't go over that because honestly, like I feel like inheritance is much more common in Java. Like I use inheritance much more in Java. Python is more just for like simple scripting and stuff like that. Okay, yeah, so we have about 5 minutes left. So what I'll do is I'll just quickly review everything that we did today. We got through a lot of material, which is good. But if you guys are comfortable with everything and just want to see the code after class, feel free to leave if you need to.
Can you please scroll to the very bottom of vehicle.py?
Yeah.
So what exactly is self doing in this? Self.color, self.temp.
Just like this, I think it's just like this in Java. It's the same kind of.
So correct. So like, okay, I got it.
Mm-hmm. Yeah, so the class is over if you feel comfortable with everything. But if you want to stay for the review, yeah, you can stay as well. Yeah, exactly. Someone's saying that in the chat right now. You can have vehicle, then you can have gas car versus electric car. Exactly.
Can you please scroll down to the bottom of vehicle.py?
Yeah. Also, I know I haven't said this in the past, but like if you guys have other questions, like whether it's Java, Python related, or just software engineering, coding in general, I'm always here to answer any questions you guys have about that. Yeah, so here we have our board, which is what we created in the beginning. So remember, this is just the dictionary representation that has each key in our Tic-Tac-Toe board, and then whatever value is at that place in the board. Then we created our dictionary with this for loop that basically defaults to whatever the default board. And then we created a function just to print the board. There's many different ways you can print this board. This is just one way that I decided to print it. But yeah. We have our check win. I'll get into that later. So I defined like an overall game. So this is our main method that executes our game. And we have two variables here. Yeah.
I just had a very quick question about the check move, actually, right on there under the try.
Yeah.
So what is the str move basically implying here? The board move is implying the specific area. So what is str move implying here?
Oh, so again, I'm just casting it to a string. So whatever the user is inputting, it's honestly, I think in this case, it's like you don't really need it, but I just included it just to make sure that it's a string. It's just casting to a string, whatever the user is inputting.
I have a quick
Alright.
question.
Mhm.
What purpose does the try serve here?
So yeah, the try statement basically is checking whether whatever the user inputted. So like notice how whenever we were here, I'll run it just to show you. So like if I were to input like an A instead of like a number, then it'll tell me that it's an invalid input. But if I didn't include this try statement and I tried doing the same thing, then it's going to throw me an error. So it basically just prevents my program from crashing, and it basically checks for these errors to make sure that like nothing will crash my program. So I see a question about how can I just keep the board in the same place and keep changing it like that. So with the program like this, that's not possible because I'm just printing out the board. But if you continue to program in like Python, you can create your own sort of like interface that can be edited. That's much more complex than what we learned in this class. But yeah, it's possible, but we're not going to learn it in this class. Yeah, so now we had our if statement to make sure that that spot in our board has not been changed yet. Then we change it to however's turn it is. We increase our number of moves just to keep track of the number of moves. And then we print if that place has already been filled. And then we call this check win. So remember, check win has basically just all the different combinations of a winning board, like a winning board state for our tic-tac-toe game. And then we return true if we find a win, and then otherwise we return false. So if check win basically just says, if this function returns a true, then I want to break from my program, meaning that the game is done. And then we have our number of moves equal to 9. So that is when every single spot on the board has already been filled up, meaning 9 moves have taken place. Then we know that there is a tie and that the game is done. So then we break again from our loop. And this is our if statement, which I did. So I just changed this to not equals in case some of you have the equals code. But yeah, this not equals basically says if my turn is not X, meaning it's O, then I want to change my turn back to X. And then otherwise, if it's already X, then I want to change it back to O. So that's how everything that worked. And then I added this at the end so that this program can continuously be executed. So we have an input that asks the user, do they want to play the game again? And then if this is a lowercase y or uppercase y, then we reset our board, we call the game again. And then if it's anything else, then we just stop our program. So yeah, so that was tic-tac-toe, pretty simple implementation of it. And then we got into a class. This is how you define a class in Python. The init method basically defines how you can initialize a vehicle, and then it has all these different parameters. Remember, self is not a parameter that you actually pass when you're creating it. Self is just Python default to refer to variables specific to that class. So self, notice I'm using self.model, self.color, just to make sure that I'm just class specific variables. And then this string function is the default, which gets called when you try to print out that object. So it will print out everything however you define it. So I can do this however I want. If I just wanted to do model and color, I can do that as well. That'll work completely fine, but I'll just include all the information. It's nice to give more information as a programmer so that if you're debugging or someone else is looking at your code, it's much easier to debug and fix. And then we created these objects. This is how we create our objects. Remember, this was a default parameter that already had a default value. So it's optional. In this case, I did not include it. In this case, I changed it to 10. And then we called our add gas, which basically adds gas to our current tank and then checks whether it's more than the gas tank. Yeah, and then we successfully added it. Otherwise, the gas tank is full, and then we ran all of that. And we got all of this information. Yeah, and I think that is it for today. So if you have more questions about classes or tic-tac-toe or this class specifically, you can stay after. I see someone just messaged me about code, their specific code questions. So yeah, if you don't have time to stay after, you can message me those questions on Slack, but feel free to stay after. So yeah, thanks for coming today. I'll be here for any questions. Yeah, Aaron, did you have a question?
Yeah, but I'll go last because like mine's pretty like long, so.
Okay. Are there any other questions as of right now? If not, you can just go. Yeah, you can just go ahead and ask me a question.
Okay, I didn't really understand like most of the vehicle.py. Like I didn't understand it whatsoever. I was just hoping that you can help me with it before I go and try it on my own.
Which program did you say? Vehicle?
Yeah, the vehicle.
Okay. Yeah. So the main purpose of a class like this is basically to just create an object. So in this case, I created a vehicle, and as I was saying, you can create one for like a circle, you can create one for like a square, you can create one for a bicycle, you can create one for like whatever object you want to do. So with this class is basically these were all attributes that I defined myself. Like none of this is like Python specific or anything. This is what I believe should go into a vehicle. Its model, its color, and its gas tank. And what this method is doing is basically on the initialization of this object, meaning when I first create this object, what do I want my values to be? And how can I basically change those values? So notice this is how I initially created my object. And what this does is basically say, okay, the model of my car, of this vehicle, whatever vehicle object this is an Acura, and the color of that is black. And by default, my gas tank has 20, as I was just saying. So this basically just creates my different attributes. Yeah, so in the chat, he's saying like a really good point right here. The init and string are built-in methods by Python that obviously you don't have to implement a method like this, but they're really helpful when you're creating these objects. But yeah, the add gas is like a user-created method that I personally created to modify the gas tank, for example. But I can also say like, I can create like another method, for example, that's like change model. And this can just take in like a self and a model, and then I can just say self.model is equal to model. So that will be basically change my model.
What's self?
So self basically is like something that you pass in to these methods in Python, into your class methods, which refer to the attributes of that specific object. So if I call self.model, that means for whatever vehicle object I'm working in right now, this is what my model is.
So self is kind of like what the class is. So like you did vehicle, so it would be like the vehicle.
Yeah, so whatever, like self is basically specific to that object, that vehicle object. So for example, like for this car, self.model would be Acura, color would be black, yeah.
Okay.
Does that kind of clear up things?
Yeah, that helps me. But for the code here, like the print adding gas, self current gas, like the gas is full, like that kind of stuff.
Mm-hmm. So yeah, so this isn't very like clean code that I created. I was just trying to do it really quickly. But what this method is basically doing is just like, this is just, as I was saying, a method that I created. So add gas. So what I want to do is basically add a certain amount of gallons to my gas tank. So this print statement is just saying, I'm adding this many gallons to how much ever is currently in the tank. So usually it'll be start off at 0. So I'm saying, for example, I'm adding 15 gallons to my gas tank, which currently contains 0. And then what this is doing is basically I created a variable that represents the current amount of gas in my gas tank. And then I'm adding the amount of gallons that I specify in my method that was passed as a parameter. So when I do self cur gas plus equals gallons, that basically takes this 15 and adds it to the current number of gallons of gas in my tank. So now my gas will be around 15. And then what I'm doing is I'm checking, I'm saying, is the amount of gas that I have that whoever tried to add to my tank, is it more than the capacity of my tank? If it is, then I want to say that my gas tank is full and then reset that value to the gas tank because it can't be greater than the gas tank, my current gas value, right?
Yeah.
So you want to reset that. And then it,
all right.
Yeah.
All right, thank you. That really clears it up for me. I wasn't understanding it. All right. Well, have a nice day.
Mm-hmm. Yeah, so it looks like we do not have more questions. So I'll see you guys all next week then for our last time. Oh, sorry, yeah.
The first program, the Tic-Tac-Toe, where does it check to see if it is only X or 0? What if I type another number, say Z?
Oh, okay. So the way that we made our Tic-Tac program, let me open that up again. So the way we made it is that the user can't really change X or O. So that it's basically by default, the turn will always either be the value X or the value O. The only thing that the user can input is where they want to place their X or O. So like they can't really, if I were to put like Z or something, that's not referring to the value in my Tic-Tac board. I mean, the input is supposed to refer to the value on my Tic-Tac board. So if they do like Z, then that's pretty irrelevant for this case. So the way that we
got
made it in X or O is by saying turn is equal to X, and then we change it to X or O through that.
Got it. Thank you.
Okay, I think that's it for questions. So yeah, I'll see you guys all next week.